What's up everyone, welcome back. So this time we're going to do a problem that is a little bit similar to the previous video. So this time we're going to find all the possible x that are integers. So in this case we do include negative integers and 0, and we have a condition that x is not equal to 3 such that the expression x cubed minus 3 is a multiple of x minus 3. And clearly, if x is equal to 3, we won't be able to conclude that, because we can see that when x is equal to 3, x to the third power is not equal to 3, meaning that x to the third power minus 3 is not 0. But then what we are trying to show is a multiple of x minus 3. In this case, it will be 0. So clearly it's not possible. Then how are we supposed to solve it? Let's pause the video and give a try. And if you haven't seen the previous video, you can go and take a look. It will actually work the similar way. Are you ready for it? Here we go. So we'll just use the same idea that we're going to take the division and trying to see what the remainder is. And again, since our divisor is a degree 1 polynomial x minus 3, we will expect our remainder to be strictly less, the degree of it will be strictly less than 1, which is either a non-zero constant or 0 after we divide it. Then if we're trying to think of it, since we have the x to the third power minus something, we can actually use the difference of cubes, which says a to the third power minus b to the third power is equal to a minus b times a squared plus ab plus b squared. Now, how is this going to help us? If we are assuming that this will be the expression of the division, then after we divide it, we will end up with some integer parts, which is the second factor here, a squared plus ab plus b squared. But it doesn't really matter what the actual form looks like, because what we care is the remainder. In this case, we will end up with some remainder. Let's call this some number k here. Then our remainder will end up being some k, let's say minus k here. Then our remainder will end up with b to the third power minus k over our divisor a minus b here. So what is our k? The k is the given constant constant term that we have, which is 3. And what it will be our a? Of course, it will just be the x, and b will be 3 here. So for the fraction parts, we'll end up with 3 to the third power minus 3 all over x minus 3. And as we simplify it, we'll get the numerator be 24 over x minus 3. Now, once again, we want this fraction to be a whole number, implying that the denominator must be some factor of the numerator 24. And in this case, of course, we can include both positive and negative factors. So we will have x minus 3, the denominator, could be equal to the factors of 24, which would be positive or negative 1, positive negative 2, positive negative 3, positive negative 4, positive negative 6, 8, 12, and 24. And as we try to solve for all these possible values, we'll add 3 on the right side for each possible value. We will get either 4 or 2. And then we have 5 and 1. We have 6 and 0. We have 7 and negative 1. And then here we get 9 and negative 3, 11 and negative 5, 15 and negative 9. And finally, we get 27 and negative 21. And these will be the possible answers, and these are all the integers that will satisfy our condition here.